And DeMoivre's theorem is really nothing more than what we already learned, right? So we said that if Z1 is equal to R1 I sine theta 1, and Z2 is equal to R2 I sine theta 2, then Z1 times Z2 is equal to R1 R2 sine, and you just add the arguments, correct?
Yeah.
What if I change this to not Z1 times Z2, but Z1 times Z1?
It'd just be all of this.
This would be R1 squared. And this guy would not be I squared. This would be 2I1, correct? Because you're adding I1 times plus I1, right? But they're the same thing. 2I1, right? What if I said, so this would be Z1 squared. What if I said Z1 to the fourth? It would be this to the fourth.
And that's a 16?
And this would be just,
Oh, just 4.
because you're adding each one, right? Does that make sense? So DeMoivre's theorem really is Z to the nth power is this to the nth power n times theta 1. Okay, so that is DeMoivre's theorem. Top of page 507, there's a blue box that indicates that. Go ahead and read that and see if that makes sense to you. So, let's see if we can actually use this. So example number 5. Example number 5, it says do 1 plus root 3I to the third. To the third. Okay, so if I did not use DeMoivre's theorem, I would have to do this how? I would have to go right? This is what I'd have to do, right? I guarantee you this is going to be really messy. Right? Okay, so let's not do it that way. Let's use DeMoivre's theorem. So in order to use DeMoivre's theorem, we have to put this guy into R I sine theta, correct? So let's go ahead and do that. So if I change, so let's go ahead and see if I can solve this guy first. So R would be what? Square root of 1 plus this squared, which is this, right? Which is 2. So I'm going to pull the 2 out. Okay. So cosine theta is this, sine theta is this. They are both positive, which means they are in the first quadrant. Yay, easy. Cosine 1/2 is equal to, which theta is cosine 1/2? Pi over 3. Pi over 3, right, for sine, right? Okay, so this becomes, right? So I've successfully transformed my Cartesian regular form complex number into a polar form number, and I'm looking for the third. So it's to the third, which means it's 2 to the third I sine 3 times pi over 3. Oh, look at this. They cancel out. So I'm going to get 8 I sine pi, which is basically what? So this is going to be 8 cosine pi plus I sine pi. Sine pi is 0. Cosine pi is no, -1. How beautiful is that? The answer is -8. The answer is, I'll move it over here, -8. So everyone can see, -8. See how simple that is?
Give me a second.
Huh?
How is this hard?
How is this hard?
Don't jinx it. What are you talking about?
It'll get there. It'll get there.
No.
Okay, that's example number 5. Let's go to example number 6. Now we're going to do the 8th. Oh, this is a Brooklyn special. Root 2 over 2, just like she likes it. Okay, so we're going to do it to the 8th. So I have to make sure that this guy is in polar form first. So let's see if I can do that. I can transform this into polar form. I'm going to do the R is going to be this squared plus this squared, which is what? 1. Okay, so actually this is a unit number, right? Because the modulus or the magnitude is 1, right? Now I need to find the argument or the angle. Cosine is negative, sine is positive. Which quadrant? And second, right? Second, okay? So this is going to be 1 times I sine second quadrant. Okay. All right. And we're going to do this to the 8th. So it's this to the 8th. This times 8. Times 8 is what I meant there. Okay. So 1 to the 8th is 1. I sine 2 6 pi. What is sine 6 pi? So this is the same as cosine 6 pi plus I sine 6 pi. Sine 6 pi is the same as sine 2 pi, correct? So it's 0. Cosine 6 pi is the same as cosine 2 pi, which is 1. So we're at this page, and the answer, yes, indeed, is 1. Okay? Let's go. Now, the reverse calculation of DeMoivre's theorem is finding the roots. In other words, so in this one, I gave you this guy, right, to the nth, and we figured out what the number was, right? In the roots, I'm going to now give you this number here, and you have to fall back and find this. Okay, so this is a little more complicated. Just as Brady was complaining that it's not complicated enough, so let's make it a little complicated. Example number 7. If you go to page 508 in the middle, there's a blue box. Complex number v is equal to a plus bi is the nth root of z if v to the n is equal to z. Okay, you see what I'm saying? What we did? Okay, the same thing I had on the board. If when z is equal to 1, you call it the nth root of unity. Unity being 1, right? Unit circle, right? Unit vector, 1, right? 1. Okay. So if you go to, so let's say that we had, I don't know. So let's say that we had v is equal to r I sine theta. And I told you that this to the nth is going to be equal to z, right? Basically, that means that this is going to be equal to z, correct? Right? So you have to figure out what z is in polar form. So I want to transfer this guy into polar form. So let's say this was 1. Let's say this was 1. It was unity. If it was 1, I need to find, this is 1 I sine what? Because this here is what? This is 1 plus, so it's cosine theta plus I sine theta, where this is equal to 0, and I have this is equal to 1, which means that theta is going to be equal to what? 2 pi, right? 2 pi, cosine 2 pi is equal to 1, right? So this is going to be 2 pi. Right? So I know that r to the nth is equal to 1, which means that r is equal to 1. And then I have here, I have correct? So this is where it gets tricky. This is where it gets tricky. When figuring this out, you cannot just merely go and say this is the same as that. It doesn't work that way. You go to page, top of page 509. Okay, what does it say? Theta is equal to n 2 pi k. Okay. And the numbers you're going to use for k is if n is equal to 5, k is going to be equal to 0, 1, 2, 3, 4. If n is equal to 6, it's going to be 0, 1, 2, 3, 4, 5. If n is equal to 3, it's going to be 0, 1, 2. Right? You think of it this way. If it's 3, you're going to have 3 solutions. Correct? First solution is 0, so it'd have to be 0, 1, 2. If I had 7, if I'm dividing by 7, right? I'm looking for the 7th root. Right? If I'm 7, I'm going to have 7 solutions. K is going to equal to 0, 1, 2, 3, 4, 5, 6. You're going to have 7 solutions. Okay? All right, so I know it's kind of a little, still kind of hard to get. So let's go ahead and work example number 7 and see how it works. Finding the 4th root, find the 4th roots of that. So z is equal to 5 I sine pi over 3. And I want to find the 4th root. So it's going to be to the 4th. The v to the 4th is this guy. Right? So v is going to be equal to 4, 5, right? 4th root of 5. Then I'm going to have cosine pi over 3 plus 2nk over 4, right? So I'm going to do this easy way, I sine. Okay. So the first one is going to be equal to what? K is equal to 0, right? K is equal to 0, so oops, this is 2 pi, not 2n. It's going to be 0, so the first one's going to be what? Pi over 12? Are we good with that?
Yeah.
Pi over 12. So this one is going to be, so let me go and put this over here. Pi over 12. The second one's going to be what? K is equal to 1, right? So that's going to be what? K is equal to 1, so it's going to be 2 pi. I have to add 3 pi over 3 plus 2 pi would be what? You see that? You divide it by 4, so it's going to be right? When k is equal to 2, it's going to be what? 4 pi, because it's, right? 2 times 2 is 4 pi, plus 1/3 pi, so it's going to be 4 pi plus pi over 3, which is 3, 12, 13. And I divide that by 4, so my end result is going to be that. So it's going to be right? When k is equal to, the last one would be 3, right? So it'd be 6 pi right? 19 pi over 3. You're going to divide that by 4, so it's going to be right? So let's think about this. From here to here, how many did I go? 6 pi over 12, which is
There's a pattern. Pretty crazy.
if I plotted these, they're going to be 90 degrees apart,
So,
which makes sense because I'm starting with this guy. This is my first one. Then you go 90 degrees here, 90 degrees here, 90 degrees here. They're going to be 90 degrees apart because I've asked for the 4th root. If I ask for the 6th root, how many degrees are they going to be apart? 60 degrees, right? So that would be a good way to verify to make sure that you've done this correctly. Okay, are we good? Very good. So let's do example number 8. Find the cube roots of -1. So this is pretty simple because it's the cube root, right? So I'm looking for cube root is -1, right? So I need to find this put this in polar form. Be 1 I sine, so this is going to be -1 plus 0 I, right? So the cosine is -1, sine is 0, which means that the argument is going to be what? Where is cosine 0, cosine -1, and sine 0? Pi, right? So cube root of this, so it's going to be this. Right, the first one is, and then k is equal to 0. This is 3 because it's a cube root. So it's going to be pi over 3. When k is equal to 1, 2 pi plus pi is 3 pi divided by 3. So it's going to be pi. When k is equal to 2, 2 pi times 2 is 4 pi, plus 1 is 5 pi, divided by 3. So this I'm just going to write as, this is just 1, right? So that's your 3 answers. If you plot them, you start here. Then you go 120 degrees over here, 120 degrees over here, which makes sense, right? Because there's 3 of them. Okay.
Okay, so why is -1 in polar form -1 plus 0 times I?
Well, no, this is not polar form. This is just regular form. This is the polar form right here. Right? Because now from here, I need to find 1 squared plus 0 squared, which is 1. Then I have to find where I have to find the argument, the angle. So the cosine is -1, sine is 0.
So there is no sign.
There is no sine. Okay, so let's go ahead and do the last one. Example number 9. Did we do 8? Oh, we just did 8, right? We just did 8. Let's do 9. Example number 9. Find the eight roots of unity. So, right, of unity, but it's 1, right? Unity is 1. 1 again this is cosine something plus I sine something, where it's 1. So this has to be 1 and this is going to be 0, right? So what is that? 2 pi. So, 8th root of 1 is equal to 1, so I'm not going to write it anymore. All right, there's no need to do that. So I sine the first one is going to be when k is equal to 0, correct? So when k is equal to 0, this is 0. So it'll be 2 pi over 8, which is going to be, that's the first one. Second one is k is equal to 1. 2 pi plus 2 pi is 4 pi. Divided by 8 is k is equal to 2, right? Would be what? 4 pi plus 2 pi is 6 pi divided by 8. Fourth one would be when k is equal to 3. So 3 times 2 pi is 6 pi, plus 2 pi is 8 pi divided by 8 is pi. And as you can see, I'm adding what? 1/4 every time, right? One, 2, 3, 4, 5, 6, 7, 8. The last one would be? Yep. One, 2, 3, 4, 5, 6, 7, 8. So actually on the test, you would have to write this out as what? This is going to be cosine pi over 4 plus I sine pi over 4, which is root 2 over 2 plus root 2 over 2I, right? This is going to be equal to cosine pi over 2 plus I sine pi over 2. So this is going to be 1. This is going to be 0. So it's just going to be I. And so on and so forth. You'd have to write all these out, right? So chances of me asking you the 8th root of something is very slim, because then I'd have to read every single one of them. I don't want to do that.
You don't want to do that?
4.
I don't want to do that.
4.
But you understand the point, right?
Yeah.
All right, we're done.
I'm gonna have to go over this in the recording.